So in section 2.4, we're going to talk about the angles inside a triangle. And a triangle uses the triangle symbol when we're naming a triangle. And that's the union of three line segments for 3 points that are not in the same line. So here we have a diagram of, this could be called triangle ABC. It could also be called triangle BCA. The name of the vertices will not affect the diagram that we're talking about. And so then we have some points. Here's point E. That is considered on the triangle. Here we have point D. That would be considered in or inside the triangle on the interior. And then we have point F. That would be considered outside or on the exterior. On the outside or on the exterior of the triangle. So we have those descriptions. Each of in layman's terms, the corners are called a vertex. Together, the plural of vertex is vertice. And the line segments AB, BC, and AC are the sides. And points can be on the interior or on the exterior, or actually on the triangle. And so my sides here would be sides AC, the segment AC. Sides and vertices. Now, how do we categorize triangles? Well, first of all, we can categorize triangles by what their sides look like. A scalene triangle has no congruent sides. If you look at this diagram, none of the sides have the same measure as each other. That would be a scalene. An isosceles triangle has two sides that are congruent, and so the single ticks there are saying that those two sides are congruent. So that would be another example of an isosceles triangle. And then the phrase equilateral. The word lateral means side. Lateral, that's the word that means side. Equilateral means all three sides are equal. So if you see in this diagram an equilateral triangle, all three sides have the same measure. So scalene, isosceles, and equilateral are descriptions based on the sides. You can also describe triangles based on the type of angles. So an acute triangle, all three angles are less than 90 degrees. In an obtuse angle, in an obtuse triangle, one of the angles is obtuse. It's greater than 90 degrees. In a right triangle, one of the angles is exactly 90 degrees. And then we have the phrase equiangular, equal angles. For an equiangular triangle, all three angles are congruent. And so here is a single arc and a single arc and a single arc. That's our notation in our diagram to say the measure of all three of these angles is the same. So if we're going to fully describe a triangle, we're going to describe it based on its sides and its angles. So here I have triangle HJK. So we're going to draw this. It's not shown. We're going to have to draw it. We are told the measure of length HJ, the measure of segment HJ is 4. And we're told that the measure of segment JK is 4. Okay, so the point J is in both of those segments. So if we have to draw a picture, if we have to try to put together a diagram, we're going to put, here's J, and from H to J, that's going to be of side length 4. We're also told that the measure of angle J is 90 degrees. So we're going to put in our 90-degree notation there. And we're also told that the length of segment JK is 4. So we'll finish off our triangle. All right, so this has a right angle. It has a side length of 4 and a side length of 4. So as far as angles, we would call this a right. And as far as the side lengths, we have two side lengths that are congruent, right isosceles. Right isosceles triangle. How about if I had a triangle that looked like this? A, B, C. None of the three sides are congruent, and obviously I have an obtuse angle. So we would call triangle ABC, we would call that an obtuse scalene triangle. All right, so it's just a matter if you're looking at the measures of the angles or if you're looking at the measures of the sides. And often we'll look at both. Now here are some properties that are true about triangles. The sum of all the measures of the interior angles is always 180. We're going to use that so often. When you add up the measure of all three angles in a triangle, it's going to equal 180. And a corollary to that, you know what? If all the measures of the angles of a triangle equal 180, and I have an equiangular triangle, that must mean that each of those three angles is 60 degrees. So I already know that the measure of all the angles in an equiangular triangle is 60 degrees. All right, another property of a triangle is sometimes you will want to extend the line, extend the side, which will create an exterior angle. An exterior angle. And I could extend this segment here. I could extend it past B. You can extend any of the sides in either direction. But here, if I extend side BC through point D, I'm going to create this angle. I will call it angle 1. That would be considered an exterior angle. All right, well, if the sum of the three angles in a triangle will equal 180, and you know what? The measure of a straight line is 180. We're not going to be surprised that here, if I have this triangle, we'll call it triangle A, B, C, and we extend the line to make angle 1. Angle 1 is an exterior angle to the triangle. Angle B and angle A are considered, if we're talking about this exterior angle, the other two, angle A and angle B, are called remote. In other words, they're not touching. Interior, because they're on the inside of the triangle. These are the two remote interior angles. They're the non-adjacent. Adjacent means touching. This would be the adjacent angle. The non-adjacent angles are the remote interior angles. And you know what? The measure of the exterior angle is going to equal the sum of the measure of the two interior angles. And we're not surprised by that, right? Because if these three angles equal 180 and these two angles equal 180, then this one must equal the other two because they both equal 180.